Hi everyone, I will be starting the second problem today. It finds little bit it finds it little bit difficult when compared to the previous problem, and the methodology also to determine the this one determinant is also a little bit different. I'm going to teach you the second method of finding the determinant. Okay, so hopefully today you will come to know the uh, other part of solving the Newton's method. But procedure remains what same till the determinant. After determinant, how we are going to solve it? What are the assumption we make to solve the problem? That we are going to see that one today. Okay, so today we will going to solve one more problem. So let's see how the time permits. Probably today, I will be giving you one or two problems as an assignment. So please be careful about this. Okay. Thank you very much. So let's start. Okay. So the problem what I am going to start today is on the left hand side of your screen. Okay. So that I will take it as problem number 2 today. So first thing is we are as usual we are supposed to write the what do you call we are supposed to write the equation of motion. So as usual, how many m's are there? 3 motion masses are there. First, I will start with the first mass, which is at the top. Okay, then I will go for the middle one. Then I will come for the third one. And already, if you see here, the bottom part, I have got k by 2, which are in parallel. So first, I will try to get that one. Okay, so the one which I am talking now here, right? This particular part. Okay, so this particular part k by 2 is there, so which I will try to what k by 2 plus k by 2, since they are in parallel. Okay, my k equivalent will be equal to k only. Okay, so then right, so my problem as simple as that. Okay, will become okay, so this will be my k k k k k k m m m. So this is how it will get converted, right? So this will be my x1, this will be my x2, this will be my x3 part. Okay, if you remember, already we have solved this one for what you call equation of motion, if you remember properly. So I will start, I'm going to start with the what you call first one here. I'm going to start with this first part. Okay, so let's start with this. So what is this? M M x1 double dot m1 x1 double dot. Now if you see that one, this m, what I have got here is connected with, okay, is connected with this k this k and this k, 3 k's. It has been connected with 3 k's. So I can say m1 x1 double dot plus, first I will take the first one, which is at the topmost, k into x1 minus 0. Correct or not? X1 is greater than all. This one is equal to, sorry, yeah, I can make it plus, or you can do it, that's also, or plus, if you are, okay, probably you will get confused. Okay, I will do one thing. I will erase this. I will also erase this one also. So that is equal to minus times of k into x1 minus 0 minus k into, right, x1 minus x2 again minus k into, right, I'm talking about now this particular part, k into x1 minus x3 is equal to, sorry, okay, this becomes now, right, then my equation becomes m1 x1 double dot minus k into x1, sorry, plus k into x1 plus k into x1 minus x2 plus k into x1 minus x3 is equal to 0, right? Then if I solve this one, m1 x1 double dot plus, let's segregate all k's, okay? Segregate all k's here. So how many k's are there? If you check it out now here, with respect to x1, one is, I will take a different color. One is this, this, and this, correct? So I will say 3kx1, correct or not? 3kx1. Next, what about x2 now? So I have got a x2, only this particular part, and x3 is this one. So both you can check it out. Therefore, that becomes minus k into x2, correct? Similarly, minus k into x3 is equal to 0. Beautiful. So this becomes my equation number, what do you call, 1 here, right? Similarly, I will go for the second one, second equation now. Okay. So if you go for the second equation, second mass, you can call it as, okay. So what is that? M into, so it is not, 1 minute, 1 minute. I have done one small mistake here. I have to erase this. Yeah. Okay, now it's okay. Now I will start with m into x2 double dot, right? x2 double dot. I'm going for the second mass now. I will take the first, I will take the, what do you call, first I will go for the upper one, then I will come for the, what do you call, bottom one. Then this mass is also connected with one more, that is this one. Correct or not? So you have to be a little bit careful while solving these problems. Okay. M into x2 is equal to minus times of k into x2 minus x1. I'm talking about the first one. Next, minus k into x2 minus x3, right? Minus again k into x2 minus 0. Last one, which I talked about, that is this one. Okay. So when I rewrite this, mx2 double dot plus k into x2 minus x1 plus k into x2 minus x3 plus k into x2 is equal to 0. This is your equation, right? Let's see what all the x1s we have got here. So I can write mx2 double dot. Only one x2 is there if you check it out. This is the one, that is minus k into x1. Correct? Minus k into x1. Then let's say all x2s, 1, 2, and 3. Correct or not? So how many there now? Plus 3k x2, right? And x3 is only this one. That is minus k into x3 is equal to 0. This becomes my second equation, right? And lastly, I will go for the third mass here, right? I'm going for the what one? I'm going for the third mass here. So this is the mass what I'm going for now. Okay, it has got how many now? This particular mass has got how many now? It has got 1, 2, right? So let's talk about this. 1, 2, 3, 4 actually. Okay, so let's talk about this. What is this? M. Okay, M x3 double dot is equal to minus k into, I have taken this minus k into x3 minus 0. Correct or not? This particular mass, if I take, that becomes x3 minus what do you call 0. I will take the upper one now. I will say minus k into x3 minus x2. Correct or not? x3 minus what do you call x2. Correct? x3 minus x2. So this is how it. Then automatically last one what I have got here is one more spring is being connected with this, that is minus k into x3 minus x1 is equal to 0. This particular. Okay, so this is how it works out now. Okay, so this is how it has come down now here. So if I write this particular equation, okay, so what I'm going to get mx3 double dot, okay, mx3 double dot, how many? So I will straight away write this plus k into x3 plus k into x3 minus x2 plus k into x3 minus x1 is equal to 0. Okay, so now I will say mx3 double dot plus k into, sorry, I will say how many x1s are there. Okay, first I will start with x1 here. Okay, first I will start with x1 here. How many? Minus x1, correct or not? Only this particular part. Minus k into x1. x2 is also 1. You can check it out. Minus k into x2. And lastly, k3 is 1, 2, and 3. Plus, so k into x3 is equal to 0. This becomes my equation number, what do you call, 3 here. Okay. So now, so I have got 3 equations. If you see here, I have got all the 3 equations, which you can check it out, right? I will just zoom out a little bit, so you can check it out here. So 3 equations have been given to me. So using these 3 equations, I have to develop the, what do you call? So let's rewrite this particular 3 equations, what I have got here. Okay. Yes, I will make sure. mx1 double dot plus 3kx1 minus kx2 minus kx3 is equal to 0, right? Then mx2 double dot minus kx1 plus 3kx2 minus kx3 is equal to 0. Then mx3 double dot minus kx1 minus kx2 plus kx3 is equal to 0. I have written like this. Right, now I have to get the, what do you call, mass matrix and this one. Correct or not, Baba? So how to get the mass matrix here? How to get the mass matrix? It's very, very simple, right? M, M, M. Right, M, M, and M here. Right, this becomes 0, 0, 0, 0, 0, 0, x1 double dot, x2 double dot, x3 double dot, plus I have to get the stiffness matrix. Now here, what is this? 3k minus k and then minus k. Again, second equation, minus k, 3k, minus k, minus k, minus k, and k. Then this becomes x1, x2, x3 is equal to 0. See the beauty now here? Okay, let's get it out this one, right? So let's see. Correct or not? It's a pakka symmetric matrix. Beautiful. Okay, Baba. So whatever the equation we have written, it is perfect. Right. Then what's the next part? Next part will be assuming small x is equal to capital X sine omega t. Therefore, x double dot is equal to minus omega square capital X sine omega t. So this is the assumption what we are going to make. So then I have to substitute in equation number 3, right? Substituting in equation 3, what I'm going to have if I substitute this, right? So this equation remains as it is m0 0 0 m0 0 0 m. Okay, just I could have skipped this what you call a step, but still I want to understand how we have gone with this one, so that since it is only a second problem, we can, okay, minus omega square x1 sine omega t minus omega square x2 sine omega t minus omega square x3 sine omega t, right? Plus 3k minus k minus k minus k 3k. I think we have done one small mistake. I think so. Yeah, right. I made out. So here in third equation, I hadn't written this. See there, this one, and this one. It has to be 3k, right? I just remember that one. Okay, then it has to be 3k here. Then it has to be 3k here. Sorry for that one. I did small mistake there. Okay, minus again k here, minus k and 3k here, right? Then this becomes what do you call x1 sine omega t, x2 sine omega t, x3 sine omega t is equal to 0. This becomes equation number 5, right? So once I got this particular equation, okay, then I have to, you know that one, I have to merge this. Okay, what happens now? The equation of mine will be now here, right? 3k minus m omega square. Correct or not, Baba? 3k minus m omega square. That becomes 1. Then again, this becomes what do you call? Then I go for the other diagonal. Same thing here also. 3k minus m omega square. 3k minus m omega square. Correct. And all others will be minus k, minus k, minus k, minus k, minus k. And this becomes x1, x2, x3 is equal to 0. So let's say this as equation number, what do you call, 6, right? So now once I got this, what is the next part? I have to get the determinant out of this, right? So that means whatever the equation I have got here, just I will go small little bit. I will say 3k minus m omega square, 3k minus m omega square 3k minus m omega square minus k minus k minus k minus k. It becomes 0. Now this is your, now I have to expand this particular pattern. The thing here is, when we try to expand this particular problem, what happens is, I can't, when you compare the previous problem with this one, what happened is, in the previous problem, if you checked out, I don't know whether you have gone through that one or not, okay, in this particular page, it was 0 here, and it was 0 here. So easily we could have what you call get that one into the separate one, and I could have solved this. But here we can't do that one because I am not having a 0 here. So what is the other way around now here? Okay, so what I will do is I will convert this what you call equation now into other modified part. Just see here what I'm going to do. Okay. 3 minus m omega square by k. I'm taking k outside. Got it? What I said? I'm taking k outside. When I take k outside, when I take, when I when I take k outside here, okay. So what I'm going to have here is minus 1 here, again here also minus 1. Correct or not, Baba? Again, in place of k, I will say minus 1. Again, in place of this 3 minus m omega square by k. See properly here, it is again minus 1, minus 1, minus 1, 3 minus m omega square by k is equal to 0. Now you understood probably because, see, hopefully you are now getting what I did. I have taken k outside. Got it? What I have done, I have taken k outside again and again. I am telling you, k taken outside. Okay, I have taken k outside. So the equation becomes like this. Once the equation becomes like this, again I have to do one small, because when I try to solve the problem, it becomes too heavy, right? I have to use the terms m omega square k and all. There is also other reason why I have taken k outside, which I will tell you at the fag end of the problem why I have taken like that. Okay, so that's why I called this as other method of solving the problem. Okay, so you can check it out with this. Concentrate on this one, how I am going to solve this problem. Okay, 3 minus m omega square by k. Okay, now what I will do is to, if I want to solve this, get the determinant, it becomes heavy using almost m omega k and all the terms will come into picture. So I don't want to do that one. I have to a little bit simplify this one. So what I'm going to do is substitute m omega square by k is equal to alpha. I'm going to substitute m omega square by k is equal to alpha. So when I do that one, my equation becomes very simple. 3 minus alpha minus 1, 3 minus alpha minus 1, minus 1, minus 1, minus 1, minus 1, and 3 minus alpha is equal to 0. See the beauty now here? Correct or not? It becomes so easy now to solve the problem. Alpha is equal to what happens? M omega square by k, I have put that one. So that's why the only step where most of the people will, what you call, do find this one is, what you call the m omega square by what you call k. M omega square by k. So you have to be little bit careful, especially this particular part. That's why you have to be careful. Okay, so k has been taken outside here. Okay, so please check it out with this. Okay, so now this is what happens. Done. Okay, now let's go back. Okay, so this is what I want to have. I'm going to expand this. When I try to expand this, okay, so let's see what happens. 3 minus alpha 3 minus alpha, open the bracket, correct or not? 3 minus alpha, then 3 minus alpha whole square minus 1 plus 1 into minus 1, 3 minus alpha minus 1. Please go on checking what I am doing. Minus 1, 1 plus 3 minus alpha is equal to 0. Correct or not? Please check it out here. Okay, what I have done, 3 minus alpha, okay, and then 1 into what is minus into minus plus, this becomes plus, correct or not? That's why it becomes minus 1, 3 minus alpha into minus 1, minus 1 into 3 minus alpha, right? It was plus here, then it became minus. It was minus here, it has become plus here. Okay, so then if I expand this particular part, okay, let's check it out. 3 minus alpha whole cube minus 3 minus alpha. Correct number, first equation. First equation. Then plus minus, I'm going to expand now this one. Minus 3 plus alpha minus 1. Again, minus I will take, right? 1 plus 3 minus alpha is equal to 0. UT. Okay. So now, again, if I move to expand this, 3 minus a minus b whole cube. Correct or not, Baba? A minus b whole cube. So what happens if I say a minus b whole cube, a cube minus b cube minus 3ab into a minus b. Correct? So in that particular way, I am going to have in that particular way, I am going to have 3a minus b whole cube. Again, I have told you a cube minus b cube minus 3ab into a minus b. 27 minus alpha cube minus 9 alpha, correct or not, into 3 minus alpha, right? 3 minus alpha. Then minus 3 minus alpha minus 8 plus 2 alpha is equal to 0, right? Then, right? So then what is the next answer, right? Then if I simplify again this particular part, it becomes 27 minus alpha cube, again minus 27 alpha, correct or not? Minus into minus plus 9 alpha square, right? Minus 3 plus alpha minus 8 plus 2 alpha. For your thing, I am doing all these things just so that you easily understand it. Otherwise, I could have written the answer directly here. So please be careful about how to check it out with this one. Then it becomes, first I will take minus alpha cube plus 9 alpha square. Okay, you got then what do you call 27 alpha, correct or not? Then it becomes minus 24 alpha, then 27, 8 and 3, right? Then it becomes plus 16 is equal to 0. Then my equation becomes alpha cube minus 9 alpha square plus 24 alpha minus 16 is equal to 0. So now we have come to what you call a thing wherein we can say what do you call this is equation number 6. I forgot to write the equation numbers here. Equation 6, equation 7, equation 8, equation 9, and this is 10. Okay, lastly this will be your 11 equation, right? This is your 11. Now if I take the root of this, if I take the root of this, alpha 1 is equal to 1, alpha 2 is equal to 4, and alpha 3 is equal to 4. This is the answer if I take the root out of this. Okay, so this is what I have got here. Now, so I will take this as my 12. The beauty of this one now you will come to know what is this. Okay, why I have taken k outside. Let's go back. What is this? Right? What is this? M omega square is equal to alpha. Correct or not? So this is what the assumption we did. Correct or not, Baba? This is the assumption what we did. M omega square by k is equal to alpha. Now you understood. Okay. Now why we have taken what you call this particular part m omega square by k here. Why we have taken k outside? The reason why we have taken out k outside is if I take k outside, m by k, what I am going to get, all the equations what I am going to solve for omega, that is frequency what I needed, will be in terms of root k by m. Okay, so you want to check it out? Let's check it out how this happens. Okay, so let's come back here. So what is alpha here? What is the assumption we did? What is the alpha here? Alpha is equal to m omega square by k. This is the assumption what we did. Correct or not? This is the assumption what we did. Now let's start with the first what you call case. Okay. So when we are started with the first case, okay, let's say alpha 1 is equal to alpha 1 is equal to, right, 1 is equal to m omega square by k, right, Baba? Therefore omega is equal to root k by m. Omega 1 is equal to root k by m. You may ask me, sir, how directly last class you haven't written omega 1 is equal to root k by 1. You find the answer. Lastly, you summated that one and then you finalized it whether it is omega 1, omega 2, omega 3. It's a simple logic here. Very, very common sense here. Alpha 1 is 1, alpha 2 is 4, alpha 3 is 4. Right? Alpha is what? M omega square by k. So alpha is 4. So again, omega, if I take the root, I'm going to get automatically 2m or 2 root of k by m. So automatically it will be a greater value when compared to this one. Correct or not? So that's why I have written omega 1 is equal to root k. Omega as omega 1. Okay, for this particular case. Then let's go back. What I have got here? Alpha 2 is equal to 4, alpha 3 is equal to 4. That means alpha 2 is equal to alpha 3 is equal to 4, that is equal to m omega square by k, right? Therefore omega 2 is equal to omega 3 is equal to 2 root k by m. Correct or not, Baba? So this is the answer what you have got for what do you call this one. So this is the problem, okay, which gives you omega 1, omega 2, and what do you call omega 3.